All right, now I'll go back and share my screen and we'll get our notes going. All right, so like I said, there's three types of symmetry we're going to look at. The first symmetry is symmetric to the y-axis. Okay, so to tell if something is symmetric to the y-axis, I fold the graph along the y-axis. And if the graph lands on itself, then it's symmetric. Okay, so let me draw a few examples of a graph that is symmetric to the y-axis. Okay, so there's my x and y. So to be symmetric to the y-axis, it could be a parabola that comes up on each side. So notice if I take this graph and I fold it right along that y-axis, when I fold that over, this right side will land right on top of that left side, okay? So another one that would be symmetric to the y-axis could be the absolute value graphs that we were making. So notice on the absolute value, if I take my graph and I fold it right on top of that y-axis, my right side will land right on top of my left side. So also, if you cut it right down the middle on that y-axis, you got the same on both sides, okay? So symmetric to the y is the first one. Second symmetry we look at is symmetric to the x-axis. And you ought to check the x-axis. I'm going to do the same thing. I'm going to fold this graph along the x-axis, and if the top graph lands on top of the bottom, then it is symmetric to the x-axis. So the same thing, I'm going to fold the graph along the x-axis. And if the graph lands on itself, then it is symmetric. All right, let me let these people in real quick. All right, so I'll draw a few pictures of being symmetric to that x-axis. All right, so to be symmetric to the x, I could have a graph that opens to the right, so that if I took my graph this time and folded it down across the x-axis, this top part of my graph would land right on top of the bottom. And then that would work with these sharp graphs also. Same thing, right? You take this graph, fold it over the x-axis, it's going to land on itself, making it symmetric to the x. So let me pull this down just a little. So the third symmetry. If you notice, I've used the y-axis, I've used the x-axis. So there's no more axes that I can use. But the third symmetry is what we call symmetric to the origin. And y'all, if you remember, the origin of the graph is the center where the 0, 0 is located, okay? So the origin is the 0, 0 point on that graph. So we do a little bit different to check this symmetry. What we do on this one, if rotating the graph (180 degrees), and you have the same graph, then it is symmetric to the origin. Okay, so basically when they say rotating something 180 degrees, they just mean turning it upside down, okay? So symmetric to the origin, I'm going to take my page, I'm going to turn it upside down, and if my graph looks the same as when I started, then it's symmetric to the origin. So let me draw one right here for you. All right, y'all, so to be symmetric to the origin, I might have a graph come up, sort of crosses through the middle, and then goes up. Notice this graph. If this graph was turned upside down, I would have the same exact graph. So y'all, let me show you that on my calculator. One that would do that would be a x to the third power. So I'm just going to graph that on the calculator to show you. So see how that graph comes uphill left to right like I drew it on my paper? I'm going to take this graph now and I'm going to rotate it 180 degrees. So if I rotate my graph 180 degrees, it's now going to be turned upside down. But y'all look, that's the same graph. It goes uphill, left to right in the same pattern. So to check for the origin, you're turning that graph upside down and notice it's the same picture either way. Okay? All right, so what I'm going to do now is go through some of the examples that you're going to see in 7.1. Oh, now let me show you one more thing over here about these. If a graph is symmetric to the y-axis, we say that it is an even function. So an even function is symmetric to the y-axis. If it's symmetric to the origin, it is what we call an odd function. And you'll notice that on these, odd functions usually have odd exponents. The even functions will have even exponents. Now notice, if you're symmetric to the y-axis, those graphs, they're not functions because they failed a vertical line test. So that's why we have nothing that we put on those. Only the even functions because they pass, and then the origin, if you notice, they pass the vertical line test, okay? All right, so now I'm going to get into some of these. There's only like 5 problems in this section. So the first 3 problems, they want to determine the symmetry of each graph Okay, so the first three, I'm going to determine the symmetry of each graph. So they're just going to give us pictures on these. So y'all, this one's a little tricky to draw here. But it comes up, curves, and goes like that. And then this side comes down, curves, and goes up like that. So I was trying to draw that good for you. It's a little tricky drawing these graphs. But this graph, I would check my Y symmetry first by folding it over. And y'all, this side does not land on this side, so it's not symmetric to the Y. Then I would check my X by folding it over the X axis, but it does not land on itself when I fold it over the X axis. So the only thing left is to check the origin. So if I rotate my graph 180 degrees, notice I still have the same picture. So since that graph looks the same, when I turn it 180 degrees, this is symmetric to the origin. All right, then number two, y'all, let's see, I have a graph. There's my X and my Y. This graph sort of comes down and curves that way. And then over here sort of comes down and curves that way. All right, so I'm going to check symmetry, starting with my Y again. If I take my graph and I fold it over the Y-axis, notice the right side of my graph, when I fold it over, lands exactly on the left side. So that side lands right on it, which means it is definitely symmetric to the Y-axis. Now you can go in and check the X if you want to, but when you fold it over, this part hits here, where there's not even a graph there to hit. And then the origin, if you turn it upside down, this was going down. If you turn it up, it'd be going up. So it wouldn't be the same graph if you turned it 180. So the only symmetry is to the Y-axis. All right, let's see this third one here. So this one, they sort of drew like I drew a while ago. Alrighty, so I would check my Y first, but when I fold it over the Y-axis, this part here lands up here. So it's not hitting the graph, so that's not to the Y. Then I would check it over to X. Oh, look at that. When I fold it over the X-axis, this line lands right exactly on that line right there. So it is definitely symmetric to the X. And then, y'all, if you turned it 180 degrees, my graph was facing to the right here. If I turn it 180, it's facing to the left. So it's not symmetric to the origin. So it's only symmetric to the X. And if you notice, when you're symmetric to the Y or the X, it's basically cutting that graph in half using those lines, okay? All righty, next two questions they want to know, is the graph even or odd? Is the graph even or odd? So this would be number 4. And y'all, what you like about these 5 problems on this homework assignment it's all multiple choice and you're just looking at pictures, okay? All right, so this graph sort of comes down like that on that side. And then it comes down like that on that side. So remember a while ago I said even graphs are symmetric to the y-axis. Odd graphs are going to be symmetric to the origin. Also, there's another trick you can do. You can count how many times the graph touches that x-axis. It's either going to touch it an odd number of times or an even number of times. So this graph is symmetric to the y-axis. When I fold it over, it lands right on itself. So it's symmetric to the y. It also touches that x-axis 2 times down there, which is an even number. So this is definitely an even function. So 2 ways I can tell that. It's because it was symmetric to the y and it touched the x-axis twice, okay? All right, so this one's a little trickier to draw. All right, so this one comes down like that and goes up, comes down. And then this side goes up, comes down here, and then up like that. Sort of like what I would call a sine wave that alternates. So if you notice, this one is not symmetric to the y-axis because when I take this and fold it right over that y-axis, this part lands down here, this part lands up here. So it's not landing on itself, so it's not symmetric to the y-axis. So the only other thing I would check is my origin. So notice how this picture looks. This graph is coming downhill. If I turn it over, my graph is still coming downhill. So y'all, since that graph looks the same when I rotate it 180 degrees, it's symmetric to the origin. But here's another way you can check on even and odd. Remember, I can count how many times it touches the x-axis. This one touches once, twice, 3 times, 4 times, 5 times. So since this touched the x-axis 5 times, this is an odd function. All right, y'all, so that was 7.1. So what we'll do next is 7.2. And 7.2 deals with transformations of graphs. All right, so let me find one of my sheets real quick. I think I put it in my bag. All righty, so on the screen, I sent y'all this last night, and I'm going to zoom this in a little bit so you can see these graphs better. So y'all, I want to go through these basic graphs because these basic graphs you see here are going to be the ones that we're going to move around, okay? So MATLAB is going to ask you for a basic graph, and it's going to be one of these 7 graphs that I got. Now, I sent an email last night sending you this page. Now, Now, the only other option, this was like page 445 in your ebook, but I sent you this page so you wouldn't have to keep going through that ebook to look for these graphs. So the first basic graph is y equals x, which is a straight line. In MATLAB, you would have to use the line tool, plot 2 points, and draw the line. Next, you got the y equals x squared basic graph of a parabola. MATLAB, we know to use the parabola tool. Next, you got the square root function, which takes the square root of a number. That's why it's sort of flat. The third one is the one I drew a while ago, the cubing, raising stuff to the third power. And you'll be able to tell by the exponents and how the problems look as to which one of these they're starting with. All right, here's a cube root function. Takes the cube roots of the numbers. The next one we call a reciprocal function, which is y equals 1 over x. So these makes this kind of graph. And we'll play with these graphs in the future a whole lot more with the fractions. And then we know this one, that's that absolute value graph we've been playing with. So what we're going to do is take these 7 graphs and we're basically going to move them up or down, left or right. Okay, we're going to move these graphs and we're going to even reflect them across the x-axis. So y'all remember these 7 graphs, because that's what you're going to go off of, okay? So the transformations we're going to look at. First transformation, a vertical shift. Now y'all want to pull my zoom back down a little bit. Let me see. All right, so first transformation I'm going to look at is what we call a vertical shift. Vertical shift is going to move my graph either up or down. So to do a vertical shift, y is going to equal f of x plus or minus b. So you take your function, evaluate it, and then you add a number to the end or subtract a number from the end. If b is positive, graph moves up. If the b is negative, the graph is going to move down. And I'm actually going to show you all this on the calculator here. I'm going to show you all how I can move these graphs up and down by just adding a number at the end of this function. Oh, y'all, so I've already got an x cube in here. That was one of my basic graphs, right? So since x cube was a basic graph, let's see what it looks like. So on the screen, you see the graph of the x to the third. It goes right through that origin and curves up. Now, watch this graph. When I come to the end of this function and I add 5. So I'm going to add a positive 5 to the end of that function. It should move my graph up 5 units. So watch when I hit enter. And there you go. Look at that, y'all. Remember, this part right here that's crossing the y-axis, it was crossing it down here at the 0 earlier. Now the graph is crossing at a 5 on the y-axis, which means by doing that plus 5, my graph went up 5 units. Now, let me go back here, and instead of making that a plus 5, let me make that a subtract 5. So remember, I added 5, it went up. Now when I graph it from subtracting 5, notice it went to the origin. Now my graph is crossing at a negative 5. So by adding a number at the end of the function, you can move it up or you can move it down. So clear that. All right, second move. The second move we'll do is a horizontal shift. So to do a horizontal shift, you're excuse me, you're attacking the x's. So it'll be y equals f of x plus or minus a. Notice, I didn't add a number to the end of my function. I'm changing the x values that are being evaluated by that function. So we're changing the x's here. Up here, we're just changing the value of the y's, okay? So, left or right on these. But y'all check this out. If a is positive, so if you add to the x with a positive number, that graph is going to move to the left. You would think positive would move it right, but when I show you all these graphs, it actually moves it left. And if a is negative, it's going to move right. And y'all, I'll tell you, this is the one that gets most people because you think, oh, I'm adding to my x, it's going to go right. No, 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 no. That graph will really go to the left. So I'm going to show you what an x squared graph will do. So here's x, and I'm going to square it. So we know the x squared graph, when I draw this, is going to go right through the center of my graph. So y'all see my vertex at the moment is in the center of the origin. Watch what happens when I add 2 to the x's, then square it. So I'm going to go back here. So to be like this, you would have parentheses, x plus 2, close parentheses, and square that. Okay, notice I didn't add the plus 2 after the x squared. I changed the x's, then squared it. Now we said if this x was positive, it's going to move that graph left. So y'all watch when I hit graph. It was starting in the center, and guess what? It went from the center of my graph and moved left 2 units. Okay? Likewise, if I go to that graph and I make that 2 subtraction instead of addition, since I'm subtracting 2, it would move my graph right. So notice when I hit enter on that one, it was in the center for the basic graph, and now it did go right 2 units. And y'all, that's what they're going to do on here. They're going to give you equations, and you got to determine, did I go up or down? Did I go left or right? Or did I do this last move? The last transformation we'll do is called a reflection across the x-axis. So to reflect a graph across the x-axis, you'll have y equals negative f of x. So you just put a negative in front of that function, and it's going to flip it. So I'm going to change this back to my basic graph, which was an x squared. So we've seen what the x squared graph looks like, right? My basic graph is going to be a parabola that comes right through the center. But y'all, watch this. I'm going to go to y equals, and in the very front, I'm going to insert a negative. So now I got negative x squared. Watch when I graph this, y'all. It takes the graph from the top and it reflects it right across the x. So it basically is taking your graph and turning it upside down, okay? So this one turns graph upside down, okay? Alrighty, so what I wanted to do with these was go to MATLAB and show you how these problems actually look in the MATLAB and how you would plot these points, okay? Because it's very tricky graphing these in MATLAB. So let me see if I can share my screen to my homework page. Oh, it's going to make me. Let me see if it's going to let me work these. All right, I think it's going to let us do these. So I'm on number 1 here, y'all, and it says, describe how the function can be obtained by one of the basic graphs. So you had the 7 basic graphs. So since you see us exponent 2 here, we know this is going to be the x squared graph for the basic graph. But what we got to do is figure out what that plus 10 is doing. So since that plus 10 is inside the parentheses, we know that's going to move me left or right. And then we said also if A was positive, that's going to move me left. So we're looking for the one of these that says move left. So you click on D. And then right here where it says start with the graph of y equals, that's where we got to put x squared because that's the basic graph. So I use my exponent down here and put in a 2. So you got to give it the basic graph they're starting with, and you can tell by the way these look up here, okay? So check that answer. It'll tell you did good, but then we got to graph this. Now, watch how I graph this. I click on the graph. We know that x squared graphs have a parabola shape, so we click the parabola. Now watch this. I'm not worried about no points. On these exercises, once you grab the tool you want, go right to the center and click it. Look what it did. It drew a parabola. What we got to do is use these keys down here in this little box to the right to move the graph left, right, up, down, or reflect it. So now, ignore the vertical stretch and ignore the horizontal stretch and shrink. We don't cover those, okay? We're only dealing with the vertical shift, horizontal shift, and the reflect over the x-axis. We will not reflect over the y-axis in this section, okay? That'll be later on in life. So the only 3 things you'll shift, vertical, horizontal, or the x-axis. So we said up here, we're going to shift the graph 10 units to the left. So go to your horizontal, which is left and right, and you went 10 units left. So bring this little slide control over here to a negative 10. Notice it moves the graph for you. So you pick it and then you slide it with this. Save that, and then you check your answer. Okay, so I'm going to keep doing these because I want y'all to get a good feel on these. There's only one that you don't get the slide controls, and that's when you get the straight line, which is what I got right here. So the basic graph of this, since you just got an x, is the y equals x graph. They're subtracting 5 from the end, so that'd be like the b. So when they subtract 5 from the end, it goes down 5 units. So I pick C. And then the basic graph was y equaled x. So y'all watch this. When we check this answer and go to graphing it, this one, when you graph it, you're going to click the line tool. but you physically have to plot 2 points. So I use a 0 for the x because that's easy. If you got a 0 for the x and you minus 5, the y value would be a -5. And then I used a 5 for the x because I can subtract that easy. So if I put a 5 in for that x, 5 minus 5 was 0, so that point would be at 5, 0, and you click it. The straight line one like this is the only one you don't get the slide controls with. You gotta just graph your line. Pick any 2 points you want to and graph it, okay? Now, most of these will have you doing the slide controls because they're not just going to be the straight line. Now, this one is the y equals 1 over x graph, which is the reciprocal graph. And we're not even going to make you graph this. After this, watch what we do. So that plus 2 is added at the end of the function. So that's going to be like the b up or down. So since the 2 is positive, it's going to move me up 2 units. And they don't even tell you what graph you started with, right? Because they're giving it right here, 1 over x. So we would shift that up 2 units. Now this one, it was nice because they didn't make you graph it. They gave you 3 pictures. So A looks like that went down. B looks like the basic graph, the 1 over x graph would actually look like. And then over here at C, looks like all these numbers went up by 2. So I'm going to pick C, which is the one that went up, and be done. So really, since we haven't covered the fraction graphs yet, we won't really make you graph them here. We just want you to be able to look at your pictures and see those. Y'all, you can graph them on your calculators, right? Plug in 1 over x plus 2, and it'd give you the picture just like that C. All right, notice there's only 8 of these problems, y'all, so that's not bad. So look at this one, negative x plus 4 to the 3rd power. That negative is going to reflect it across the x, and then that plus 4 is inside the parentheses, so that's like an A. And when it's plus and inside the parentheses, it's actually going to move me left. So inside the parentheses is left and right, positive left, negative right. So let's look for a one that went left. So this one says left 4 units and reflect across the y. No, we don't even touch the y in this one. Shift left 4 units and reflect across the x. Yes. And remember, this basic graph is x to the 3rd power because you see that exponent 3, okay? All right, so remember, reflect x, left 4, we would check that answer. And then it's going to come in and want me to graph that. So since this is the x3rd graph, x cubes use this cubing tool. But remember, I just click the tool, you can go right in the center on this one. It's going to draw the line. All we got to do is tell it to move. So since that was plus 4, I said it would move it 4 left on the horizontal. So 4 is -4, so see how it moved it? And then I reflected it, so I'm going to reflect it over the x-axis, save that, and then be done. Okay? All right, we're getting there. Let me see what they got on number 5. All right, so this got x plus 5 squared minus 4. So the 5 is inside the parentheses, so that's like an A, left or right. Since it's positive, it's going to go left, 5. And then that -4 at the end of the function is like the B. Since it's negative, it's going to go down 4 units. So the basic graph we start with, once again, is the x squared graph, because I see that exponent 2 there. So the 5, since that was plus, we went left 5 units. And then since this 4 at the end was negative, it went down 4. All right, so we did that. And you know it's going to make me graph this. So let's go to the graph. Click to large graph. All right, so that's x squared, so we know this is the squaring function. So remember, just stick it right in the center. It's going to draw it. We went left 5, which is horizontal, 5 left. And then we went down 4, which is a vertical, down 4. So see, it moved me left and then down. All right, so I'm going to save that. All right, y'all, so we're getting there. We're keeping this homework it's sort of low. You know, you had 5 problems in the last one. All right, this is the squaring one. Now, here's the trick on this one. A radical would be treated like parentheses. So if it's under that radical, like the x plus 4 is, it's like it's in parentheses, okay? Now, to be added to it and do a vertical, it'd have to be outside the radical with a plus 4 or something, okay? But it's underneath the radical, so it's attacking the x like the a would do. So since that's a positive 4, it's going to move me left 4 units. Okay, so if it's under the radical, it's like it's in parentheses. All right, then let's see if this one's going to make me graph it. Yeah, it said graph it now. They're not making you draw it. So let's see, which one went left 4? This one went up 4. This one went down, it looks like 4. This one went right 4. So it looks like this last one went left 4, which is what I needed. Remember, these graphs always start in the origin, and this one definitely went left. So we don't need to make you graph that. We just want you to pick a picture. All right, here's a cube root. So they're saying you're going to start with the cube root. What does this minus 2 do to it? So notice this minus 2 is not under the radical no more. So it's not like the a was. Since it's outside that radical, it's like the b. It's going to move me up or down. And since that's a negative 2, we know that's going to move me 2 units down. So we would click that. And I don't think this one had to get graphed. I'm not sure. Yeah, it did. So remember, the cube root went right through the middle like C does. B looks like it went up. So I'm going to have to go with A, which went down. All right, y'all, then we had the last one, number 8. All right, let's load up. I must have some little internet issues over here. All right, this one's got all 3 of them. Look at that. It's got a negative in the front, which is going to reflect me across the x-axis. It's got a negative 7 inside the parentheses, which is like an A. And since that 7 is negative, it's going to move me right 7. And then here's my B at the end. And since that's a plus 6, it's going to move me up 6 units. So they want me to shift it. We said right 7. Then we're going to reflect it across the x-axis. And then we're going to shift it up 6 units. Okay, so let's go in there and see what your moves are. And then, oh, nice. They didn't want me to even have to graph that one. So let me stop my share now. All right, y'all. So that basically was your 7-1 and 7-2. And the trick is just remember on the graphs, you pick which one of your basic graphs you started with. And then you put it in the origin or right on the center of that graph. And it's going to pop open them controls. And then you use them controls to move it around, okay? And just remember, you never do the shrinking and the stretching stuff or the y-axis. So let's see. Anybody got questions? So y'all remember this. If you have not done my test 1 yet, it is due by Sunday night. Okay. Also, if you're going to do the bonus, I need that sent in so that I can add them to your test. I haven't added everybody's bonuses yet, but I'll get them done for sure over the weekend or by then so that everything looks right, okay? All righty, so I'm not seeing any questions, it don't look like. So we will stop recording this. I'll end this meeting and I will send y'all this video out later today, okay? So that y'all have more notes on doing that. Also remember, check your email and you will find that helper sheet that I sent with those basic graphs on it, okay? Yeah, it's going to get crazy sometimes during this COVID, you know, so I hope to see y'all, though, Tuesday live, okay? All right, y'all, so if y'all have nothing, I'm going to end this, and I will see y'all Tuesday, okay? Y'all have a good one.
All right. Have a good weekend.
You too.
Thanks. Bye.